Hi, Algebra 1 students. This is Mr. Steckler from Academy of Health Science Professions STEM. Welcome back to the last lesson for Chapter 1. This is video number 8, and section 1.8 is called Interpreting Graphs of Functions. Some vocabulary words we'll be covering in this lesson, this video, include intercept, x-intercept, y-intercept, line symmetry, positive, negative, increasing, decreasing, extrema, relative maximum, relative minimum, and behavior. So we'll look at a word problem to start with. It says the graph shows the expected revenue Y as a function of the price per unit X. Identify the function as linear or nonlinear. Then estimate and interpret the intercepts of the graph of the function. So this graph is curved. It's not linear, so we would consider it nonlinear. All the answer choices have nonlinear. Now, what's meant by the intercepts, there's going to be two intercepts on this graph. One of them will be an x-intercept where it crosses the horizontal axis. In this case, the horizontal axis is the price per unit, and that's in dollars. So the x-axis intercept looks like it's a little bit larger than 60. So in this case, the numbers that are here that have that is 62. So the x-intercept is 62, 0. And so what that means is when the price per unit is $62, the revenue is 0. So looking at that, letter A has that. We're not sure if that's the answer yet, but it has 62, 0. Letter B does not. Letter B has 0, 62, so that can be eliminated. Letter C also has 0, 62, so that can be eliminated. And then letter D has 62, 0. So it's between A and D. Now for the y-intercept, which in this case is the revenue, that crosses here at this point right here. This is approximately 0, and again, looking at the answer choices, it has to be 0, 100. And so both A and D have that. And now, which of these two interpretations is correct? Well, what this means is that $100 is a revenue. So the revenue is $100 when the price per unit is $0. But letter A doesn't say that. Letter A says 0 revenue at a price of 100. So that one's backwards. So the correct interpretation of these intercepts is letter D. Here's another graph. And they tell us that the graph shows the cost Y to manufacture X units of a product. Describe and interpret any symmetry. So symmetry means, is there a line that can cut this graph exactly in half? And there actually is. If we drew a vertical line right here at X equals 30, that would cause a reflection so that both sides of this blue graph would be right on top of each other if we folded it over. And so our line of symmetry then is X equals 30. So what that means is that the right half of the graph is the mirror image of the left half at the line X equals 30. So this symmetry tells us that the cost to produce a certain amount more or less than 30 units will be the same. So in other words, if we produce 10 more than 30, that's 40. That will cost the same as if we produce 10 less than 30, which is 20. Another graph. This graph shows the expected revenue as a function of the price per unit. So this is similar to an example we had a couple slides before. Describe and interpret any symmetry. So again, it looks like we do have symmetry. It looks like there's symmetry at x equals 30, which is a price per unit. So now letter C is out because we do have symmetry. And it looks like the other answer choices A, B, and D all talk about the right half being a mirror image of the left half. Now what's different though is where the line of symmetry is. The line of symmetry is at x equals 30. Letter A says that. Letter B does not. It says that x equals 3. So that's out. And then letter D says y equals 1,000. That's a horizontal line. And no, there's no line of symmetry at the horizontal line. If we flipped it over, we don't even have a blue graph up there. So the line of symmetry is right here at x equals 30. So the correct answer is A. And now let's make sure we have the correct interpretation. Here it says the expected revenue at a price a certain amount more or less than $30 per unit will be the same. So for example, if we go $5 more than 30, that would be $35. And if we go $5 less than 30, that's $25. And sure enough, at $25 and at $35, the revenue is approximately $960 for that price of a unit. So the correct answer here is letter A. Here's some key concepts to remember with graphs of functions. A function is positive when it lies above the x-axis, and a function is negative when the graph lies below the x-axis. A function is considered increasing where the graph goes up to the right, and it's considered decreasing when the graph goes down to the right. And again, when we talk about increasing and decreasing, we require to go from left to right. So when you go from left to right and the graph is going up to the right, like it is here in blue, that's an increasing interval. And when we go decreasing, that means the graph is going down to the right, like the red. There's two red decreasing intervals that are going down to the right. That's considered decreasing. We also have what are called extrema points. Extrema is a plural. The singular of extrema is extremum. So there are two extremum, a minimum, in this case a relative minimum, or a maximum, relative maximum. And so a relative minimum is a low point. In other words, the graph is changing from decreasing to increasing. And that's a relative minimum at this blue point, point A. And when we have a graph that changes from increasing to decreasing, the point where that change occurs is the relative maximum. In this case, that's letter B. And the last concept here is end behavior. So end behavior is talking about the graph on the far right and the far left. So this blue graph on the far right, this end behavior is going down, because as we move to the far right, the graph is going down. There's an arrow that's pointing down. And on the far left, the end behavior on the far left, the graph is going up, because as we move to the far left, it looks like this arrow is shooting up. All right, this is a very, very busy screen. So let's see if we can make some sense of it. The graph shows the speed of a car after X minutes. So the independent variable is the time in minutes. It's the horizontal axis. Estimate and interpret where the function is positive, where the function is negative, where the function is increasing, where it's decreasing, the x coordinates of any relative extrema, and the end behavior of the graph. So let's talk about where the graph is positive first. To be positive, the function has to be above the x-axis. So here's the x-axis, and it looks like it's above it from 0 minutes all the way to 7, looks like the numbers are 7.2, from 0 minutes to 7.2. So all answer choices say that. It says positive 0 is less than t, which is less than 7.2. Now it doesn't say it, but we're assuming that this blue graph continues. So it looks like it would continue down. So in that case, the graph would be negative when t is greater than 7.2 minutes. And again, all the answer choices do say that. Let's now talk about where the function is increasing. So increasing means as we travel from left to right, the graph is going upwards, up to the right. So as I'm tracing along right here, this is an increasing interval from 0 minutes to 1 minute. That's an increasing interval. So that says here t less than 1. So B looks like it could be correct. A is incorrect because it says that the function was decreasing when t is less than 1. So A is out. We're not going to refer to A anymore. Letter C is also out because it says t is less than 30. This graph doesn't even go up to 30 minutes, so it doesn't make any sense. So C is out. And now letter D is possible because it says the graph is increasing when t is less than 1. So it's between B and D. Now let's take a look at what happens from 1 minute all the way over to about 4 minutes. Looks like the graph is going down, so that's decreasing. So letter B says the graph is decreasing from 1 less than t, which is less than 4. That's true. And the same thing with letter D. It also says it's decreasing from 1 less than t less than 4. Next up, from 4 over to 6, the graph is going up. So that's increasing. So as we look at answer choice B, that does say it. 4 is less than t, which is less than 6. That's increasing. That's true. Letter D also says that. Now let's go to from 6 all the way, and we don't know. So t greater than 6 looks like it's decreasing. And the same thing here. So both answer choices say that. So it's still between B and D. Now let's talk about the x coordinates of any relative extrema. So right here at x equals 1, it looks like the graph is changing from increasing to decreasing. So at t equals 1, that would be a relative maximum. Letter B doesn't say that. Letter B says it's a relative minimum at t equals 1. So letter D is the correct answer. We have a relative maximum at t equals 1. It also says there's one at t equals 6. That's true. The graph changed from increasing to decreasing. And they said that there's a relative minimum at t equals 4. That's also true because the graph changed from decreasing to increasing. As far as the end behaviors, on the far left, it looks like the graph is going down. And on the far right, the graph is going down. None of the answer choices talked about that, but that's what the end behavior is for this one. So the correct answer here is letter D. That question had a lot of parts to it, so hopefully it makes a little bit better sense now. And that's going to complete the section 1-8, which is chapter 1. You'll probably be having a review with your teacher, and then you'll be having a Unit 1 exam very soon. So good luck on that exam, and we'll see you next time for chapter 2. Bye-bye.